In this video, we're going to be talking about the leading coefficient test. And we're also going to do an example where we're going to apply the leading coefficient test. So the leading coefficient test says that as x moves without bound to the left or to the right, the graph of the polynomial function of the form f of x equals a sub n raised to the x of n plus all the way until a sub 1 of x plus a sub 0, where our a sub n can't equal 0. It eventually rises or it falls in the following manner. So now you're like, what exactly was that saying? It's saying it determines the n behavior, right? So when n is odd, right? When n is odd, you have two choices. The a value can either be positive or the a value can be negative. And so you end up with two choices of graphs. So here on the left in our first graph, we're seeing an example of where a is positive. Notice that as x goes from negative infinity up to positive infinity, we go from negative infinity to positive infinity. Notice also that there's a left side behavior and a right side behavior of each piece. Left side, right side. And each of those pieces corresponds, or rather as part of the solution when you're talking about the n behavior. Here we have an example where a is negative. Notice that our left side is coming down and our right side is finishing that movement. N doesn't have to be odd. N can also be even. And just like with odd, when we have kind of two choices, it can either be a can be positive or a can be negative. So here we see an example where a is positive, and here's an example where a is negative. So notice that when a is positive, that the graph rises to the left and to the right. Whereas if a is negative, then the graph falls to the left and it falls to the right. If we look back up at our odd graphs here, we see that when a is positive, the graph falls to the left and it rises to the right. And when a is negative, it rises to the left and it falls to the right. And so that's how we can describe that n behavior. So something that's important though is that you need to note that the dashed portions of these graphs indicate that this test only determines what the right hand and the left hand behavior of the graph does. It doesn't tell you about the middle necessarily. Okay? Let's do an example. So here we're going to use the leading coefficient test to describe the right and the left hand behavior of the graph. So what do we need? Well, that was a little unexpected for it to jump. Let's try again. We need to know, is our a positive or negative? Is the degree even or odd? And then what that looks like, so we can talk about it. So if we look in the front, here we see that we have a negative x to the fifth minus x. So our leading term has a negative for the a, and our degree is that 5, which is an odd number. So we have a is negative and our degree is odd. So if we think about what that looked like on the examples I showed you before, that means it's going to rise on the left and fall on the right. So to describe that, if we're looking at just the left side, we'll say that as x approaches negative infinity, so as we are going this direction, that means that our f of x is going up. So as x approaches negative infinity, f of x is approaching positive infinity. Well, what about the right side? For our right side, we would say, as x is approaching positive infinity, f of x is approaching negative infinity. And that's how we would write our answers. Let's try another example. So here for b, we have f of x equals x to the fourth minus 5x squared plus 4. So we want to look at the leading coefficient because we need to determine if our a is positive or negative and if our degree is even or odd. We have a positive x to the fourth, so our a will be positive. Because our degree is a 4, our degree is going to be even. So what would that look like on our graph? If we use the examples we just saw, we know that both the left and the right sides are increasing. If a had been negative, then they would be both decreasing. So how do we word that? Well, for the left side, we would say that as x is approaching negative infinity, f of x is approaching positive infinity. Remember, we're just describing the end behavior, not what's happening between the two ends. For our right side, we would say that as x is approaching positive infinity, f of x is approaching positive infinity. And those would be considered our answers. So these pieces would be our answers. That's how we would describe the right and the left-hand behavior of our graphs.